Yeah, good evening. So, do you have any questions? So, in integral equation, how to replace ds with dx dy? Avinash, you have doubt on that? Okay. Any other doubt on the topic? I am going to explain that. Any other doubt? So, I think so. As far as the vector calculus is concerned, you people are very clear with the topic, right? As the concept basis, right? Got it or not? Now, actually, this area calculation. So, when to replace ds and when to not to replace ds. Now, actually, yesterday we have derived. Yesterday, when we calculate the integral, so this is the sphere, and then suppose let us say this is the sphere, and then actually this is the line joining. Now, here actually, when we find out this area, we have replaced it straight away with ds. And then actually there actually we didn't solve the integral and we calculate ds as the area of this triangle where this length is a, or actually so pi a square. This is how actually we will be immediately replacing as long as this length is a. Now actually why we are doing this way ds rather than actually we can even solve with the help of dx dy also, right? Is this the question you have, Avinash? How to replace ds? Yeah. So here actually the problem is, understand the fundamental problem statement. What happens is, suppose if the area is on the x-axis or actually in the plane of xy or yz or zx. Suppose actually if you want to find out is, see this. See this is a cube. So on this cube, if you notice, this cube any side, if you can think of, this is either on the xy plane or the yz plane or the zx plane. Now in such case actually if you want to find out the area, you will be straight away using dx dy or dy dz or dz dx as long as the surface is exactly parallel to the any of the standard plane. Now what if it is not parallel to the any of the standard plane? There the problem comes. Suppose if you want to find out the surface area of this particular sphere which is in the first octane, then how you are going to find out that surface area? Is there a method you can think of? You want to find out the surface area of the spherical surface in the first octane. How you are going to calculate that? Now for that actually the methodology there we are going to use is, there is no standard method, so we can use straight away as if like you can find out the ds value without using this dx dy. For that actually what we are going to do is, we will be projecting, suppose if I take this spherical surface and then on the first octane actually I am going to find out this particular surface area. So this is the surface area I want to find it out. So this is a spherical shape, not a circle. Now what I am going to do is, let us say this is x-axis and this is y-axis and this is z-axis. Now this curved surface area we will be projecting onto a known plane. That plane here it is the xy plane. Now this curved surface, if you project onto the xy plane, this is going to assume, so on the xy plane this is going to be a quarter circle like this. Correct or not? Understood or not this one? Right, so Avinash, I hope you got it. So if you project this curved surface onto the first quadrant of this xy plane, this is going to be a quarter circle like this. And then, yeah, so this quarter circle, so you will be using this quarter circle area to find out the spherical surface area in case of integrals. So maybe in case of Gauss divergence theorem, or maybe to find out the surface integral itself. So or if you want to find out the surface area itself, in all the cases actually you are using only this method. That method is, this surface is projected onto this one, then ideally this particular surface is having a normal in this direction, and then this particular surface is having a normal in this particular direction. Now actually if I say that from this actually if I draw a normal, this is going to be the normal, which is nothing but k. This is a known normal in the k direction because this is exactly perpendicular to the xy plane. But this particular surface is having a normal which is in a crossway. Now the angle between these two, let us say this is an angle theta. Then what I am going to take is, for this particular surface, that is the projected surface, this normal taken together with the surface is a vector or a area vector which is perpendicular normal to the surface. And then this is also a vector. So for this particular surface area, this is the normal vector. Now the dot product of these two, that is, let us say this is n cap, then k dot n cap. So k dot n cap is nothing but the dot product of these two, which is nothing but the projected surface area onto this one. Correct or not? So this is going to be k dot n cap getting multiplied by ds. This value is equal to dx dy. I mean to say here it is, this area is the surface area. So this surface area is ds, and this surface area, which is exactly projected surface area onto this particular place, this is having the area of dx dy, and the original area is ds, and the normal to this is k, and the normal to this one is n. Now the angle between them is these two, which is nothing but theta. Then the dot product of ds and this one, right? So this is going to be exactly equal to dx dy, which is nothing but k dot n cap times of ds. Correct or not? Or in other words, I call this as ds cos theta is nothing but dx dy. Can I say this? This is exactly what we are going to use there. Now cos theta is nothing but k dot n cap, or ds is equal to dx dy divided by k dot n cap. So this way actually you have got a beautiful relation saying that, so you don't know how to find out the curved surface area. You know only the methodology of finding out a surface area or a plane area which is exactly projected onto the any of the xy plane, or if it is parallel to the xy plane or the yz plane or the zx plane, then only you know the method of finding out the area. So for that you will be using the standard coordinates dx dy. But here this surface is not parallel to any of the standard coordinate axes. So this is a curved surface. For all kinds of curved surface, this is the only methodology. You will be projecting only onto a known plane. So this curved surface area you projected onto the xy plane. And then the dot product ds cos theta or ds into n cap dot k cap is going to be exactly equal to dx dy. Now actually I am going to give you a different methodology. Now the same curved surface area you can even project it onto this one, that is the yz plane also you can project onto it. Now the area is going to be dy dz value. This value is equal to ds into k. So instead of k, this is going to be j. So yz plane, right? Sorry, this is going to be I. So yz plane, the normal is in this direction and n cap is in this direction. The angle between them is theta, and ds into n cap dot I is equal to dy into dz, which is projected onto this particular surface. So these two will be exactly same. So it is up to you, how do you want to use that? Got it or not? So this value, so dy dz, and if you integrate on either side, the same value you are going to get it. Or you may use the other method also, that is this method, that is ds, you can get it as if like dx dy divided by k dot n cap. The same thing is even equal to dy dz divided by n cap dot I. Both are same. Understood, Avinash, now? This is the only methodology. And as and when there is a curved surface, then only this kind of method comes into picture, because with the known standard method you cannot solve it, because the plane is not parallel to any of the standard coordinate plane. Any other questions? When to replace? So I didn't get your question exactly. When to replace, we mean sometimes actually we will keep as if like it is ds and straight away proceed to the answer. That is one method we are going to do. And sometimes actually you will be projecting as dx dy and then actually solving it. So when we are, so in yesterday's problem actually we have straight away calculated this one, right? Now actually when to use, when not to use. So there is a flexibility that you can always use. But actually, when you have a simpler solution than that, then actually there is no point in doing all those things, right? So the projecting this particular surface area like this, and then actually you can calculate exactly you are going to get the same value. But actually, I know far better solution than this. That is, I know this particular circle area as long as I know this radius. I know the radius, then why I need to project this and then do the calculations all together and make some mistakes. Rather than that, I can straight away find out the area. I can still keep as like just ds and solve it. If you are not able to solve, then there is no other option. You have to project and then do it. Other than that, there is no other reason. Okay, fine. Any other questions? Anybody? Any other questions? Anybody else? Any questions? So the questions actually that are coming in the exam also, those are also actually, so not much of difficulty. You will be able to solve most of the things, right? So I'll just read through. So verify Green's theorem in the plane. So I think so that you should be able to solve it. So verify Green's theorem. Integral over the contour C, xy plus y square into dx plus x square dy, where C is the closed curve of the region bounded by, C is the closed curve bounded by y is equal to x and y is equal to x square. So I think so this was solved in the class also, I think. So can you try solving that on your own? Anybody got the answer? Okay. So he asked us to find out the Green's theorem, right? So you have to verify the Green's theorem, that's all. Got it? Anybody? Okay. So this is straightforward only. So you can solve on your own. That's not of big difficulty. If f equal to yi plus x minus 2xz into j minus xyk, evaluate double integral over the surfaces del cross f dot nds where S is the surface of the sphere, where S is the surface of the sphere, x square plus y square plus z square equal to a square above the xy plane. Can you solve this? Anybody got the answer for this? Anybody got it? Maybe actually, I think so. Two different people, so set of people actually try to solve this particular problem in two different methods. Some people actually can solve this as f dot dr format. So as per the Stokes theorem, so f dot dr over the closed contour C, where C is, this is x and this is y and this is z. Then this is the spherical shape like this, right? So on this spherical shape, so this is a closed contour. So this is the contour whose equation is x square plus y square is equal to a square. So with the help of Stokes theorem, some people actually you can solve with the help of line integral. Some people you can try for finding out del cross f dot n cap ds. Let us see if both tallies. Anybody got it? This is just finding out the surface integral and line integrals, right? Right. So Avinash, I think so I have explained earlier, right? So your doubt. Now in this case, actually to find out the surface integral, you need to project it. There is no other way for us. Find out the surface integral. You need to project on the xy plane. Yeah. So were you able to solve, or you want me to solve? Okay. So here actually, so del cross f value I j k dou by dou x, dou by dou y, and dou by dou z. And then this is y and this is x minus 2xz. This is xyk minus half. So del cross f value will be I times of, this is minus x minus minus 2x minus j times of minus y minus 0 plus k times of 1 minus 2z minus 1. So this is plus 2x minus x. So this is xi plus yj plus minus 2zk. So this is del cross f value. Got it? And the n cap value, so this is actually on the sphere, that is x square plus y square plus z square is equal to a square. So this is the spherical surface. So unit normal vector n cap is del phi by mod del phi. So this is del phi value will be 2x into I plus 2y into j plus 2z into k divided by. So this is 2x whole square plus 2y whole square plus 2z whole square under root. Now this 2 comes out and 2, 2, 2 will cancel out, and this is a square under root will be a. So this is xi plus yj plus zk divided by a. So this is the n cap vector. Now the dot product of these two, this is going to be, so del cross f dot n cap ds, del cross f dot n cap ds is going to be, so this is x into x is x square plus y square minus 2z square divided by a. So this is x square plus y square minus 2z square divided by a is the function for which you need to find out the surface. Yeah. So this surface, so integral x square plus y square minus 2z square divided by a into ds. Now this ds is the spherical surface above the xy plane. So this is the surface area. Now actually this surface area needs to be projected onto the xy plane. So this is the xy plane. So for this actually you need to project the surface. So this is dx dy. So this is the z axis. Got it? So this is the x axis. Then this is the y axis. Now on the projected surface, so this area, so n cap is coming out to be xi plus yj plus zk divided by a. So this is the n cap. Now as I explained earlier, so dx dy divided by n cap dot k. So this value is equal to ds. So ds is nothing but dx dy x square plus y square minus 2z square divided by a into, so this is dx dy divided by n cap dot k. So this is z by a. Got it? So this a and this a will cancel out, and then this is x square plus y square divided by z minus 2z into dx dy. So now actually this z actually needs to be expressed in terms of, so this equation. So x square plus y square plus z square equal to a square, and then z is equal to square root of a square minus x square minus y square. So just replace it here. X square plus y square divided by a square minus x square minus y square under root minus 2 times of square root of a square minus x square minus y square. So dx dy. I think so this way actually I think it is becoming a bit difficult. So can you try with the line integral format? So line integral format. F dot dr over the contour C. The contour is this one. So F dot dr is y dx plus x minus 2xz dy plus minus xy dx dz. So this is for the circular contour. So try this one and let us check. So meanwhile, actually, I'll just verify. Okay, anyway, I think so. We'll continue with the line integral format itself. So I will try this again and then I will post it in the Telegram group. So this one, y dx, integral y dx plus x into dy minus xy dz. So this is at z is equal to 0. This is the line integral we are talking about, right? So on this line integral, then actually this is going to be, so x dx, y dx plus x dy minus xy into dz at z is equal to 0. So this actually, you can put it in the polar form. So x is equal to a cos theta and y is equal to a sin theta. And then dx is equal to, so a into derivative of cos theta is minus sin theta d theta. And similarly, dy is equal to a cos theta into d theta. Got it? So dx dy. And then you just replace it here. Here actually dz is going to be 0 because there is no change in the value of z. Then integral y dx plus integral x dy. So this actually, if you put it in the polar form, so this value is going to be, no, we can't use Gauss divergence theorem because here actually this is a open surface, right? Gauss divergence theorem is applicable only for the closed surface. Got it, Srinivas? So this one, integral y dx plus x dy. So this can be done as y is a sin theta and then dx is minus a square sin square theta d theta plus x is a cos theta and dy is a cos theta, a square cos square theta d theta. So this is a square, if you take it out, cos square theta minus sin square theta is sin cos 2 theta d theta, and theta is varying from 0 to 2 pi. A square, so integral cos is minus sin, so sin 2 theta divided by 2, upper limit 2 pi and lower limit 0. I think this is coming out to be 0. Yeah. Got it? Okay. So there is one tricky problem which was given, I think in 2012 or so. Note down that. See this. So the sphere is above the xz plane or yz plane or the zx plane, whatever it may be. The procedure is simple and straightforward. Suppose actually this is x and this is z. Then if this is a sphere, then this is how it is going to be. The normal vector, what you are going to calculate is, this is similarly del phi divided by mod del phi is the unit normal vector. Only thing is the projection is towards the y direction like this. So this is on the xz plane, then this is j cap. So when you calculate dx dz divided by j dot n, so this is how actually you put it. Other than that, there is no other difference. Vishal, got it? Understood? Note down this problem. I think so. This was given the year 2013. So this problem is evaluate integral over the surface S a square x square plus b square y square plus c square z square whole power minus 1 by 2. I think that is not visible. I'll just write it. Evaluate integral over the surface S a square x square plus b square y square plus c square z square whole power minus 1 by 2 ds. So he didn't give n cap, he didn't give f here. That's the tricky part. Where S is the surface of the ellipsoid, S is the surface of the ellipsoid ax square plus by square plus cz square is equal to 1. Now actually he asked us to find out this integral. Here actually there is no n cap, there is no f. Then this is straight away ds he has given. Now can you try to solve this? Anybody got it? First actually you tell me what is this vector. So where actually we can get this vector f. So if you are able to identify that, you are done with the problem. Okay, so let me solve this. See this actually, this is an ellipsoid he has given. So this function phi is equal to ax square plus by square plus cz square minus 1. So this is the function phi. Now del phi by mod del phi is nothing but this is the unit normal vector n cap. Yeah, I think so. Mohammed got it. Yeah. So this is del phi is so 2ax into I plus 2by into j plus 2cz into k divided by 2ax whole square plus 2by whole square plus 2cz whole square, and this value under root of it. Now this is going to be 2. Actually if you take it out, then ax into I plus by into j plus cz into k divided by, so a square x square plus b square y square plus c square z square whole power 1 by 2. Right? So this is how actually the n cap came in. Now here actually what he has given is f dot n cap value straight away he has given as 1 by square root of, or the a square x square plus b square y square plus c square z square whole power 1 by 2. So this is, which is the denominator part of it. Then f dot n cap value is coming out to be this one. Now f dot n cap, right? So this n cap, f dot n cap is ax into I plus by into j plus cz into k divided by a square x square b square y square plus c square z square whole power 1 by 2 is there, right? So actually if it has to be equated to this one, then actually here ax by cz, this is left over. Now if f is such that the dot product of these two is coming out to be 1, then this will be equivalent to this one, the original equation, this one. Got it? So this value from this, it implies f dot ax into I plus by into j plus cz into k. The dot product of these two is 1 from this relation, right? Now the dot product of these two, if it has to come out to be 0, then actually we have got this relation ax square plus by square plus cz square is equal to 1. Then from this f can be, the only possibility is xi plus yj plus zk. So this is the only possibility, so that the dot product of these two ax square plus by square plus cz square which is equal to the value of 1. Got it? So from this actually we have got the f value. Once you got the f value, then the procedure is straightforward. Got it? Note it down. So from this, once you find out the f value, so as per divergence theorem, this value surface integral is equal to triple integral del dot f dv. So del dot f is equal to triple integral over the volume v. Del dot f value will be 1 plus 1 plus 1 into dv. So this is 3v, where v is the volume of the ellipsoid. Got it? So the volume of the ellipsoid is 4 pi by 3 to 1 by square root of ABC. So I think this is the volume of the ellipsoid. Yeah, that's correct. So for this actually 3 times of it, 3 will cancel, 4 pi by square root of ABC. Got it? Understood? So this is how actually you should be able to solve the problems, right? Mostly you are going to get easier problems only from vector calculus. This is not very tough topic. So any questions? So any questions? Okay. Yeah, so that should be fine. So today will be my last class. So I think so Satya sir is going to start up the classes from Monday onwards. So till then actually you don't have any more classes. So if you have any questions, you can let me know. So after Satya sir finishes the classes, then only I will be coming back again. Got it? Yeah. So if you have any questions, you can put it on Telegram also. So I can help you out in case if you have any doubt. Yeah. Okay. Yeah. So till then, yeah. Bye bye. Yeah. Thank you.